Researchers at NASA's Kennedy Space Center in Florida are developing new metal alloys that, when damaged, can repair themselves. This innovative technology, called SMASH, for Shape Memory Alloy Self-Healing, could provide improved safety margins to future spacecraft landing on a distant planet. Aircraft, as well as spacecraft, can be subjected to material fatigue, the progressive and localized structural damage that occurs when a material is subjected to repetitive stress. SMASH technology could be used to self-repair these parts. Earlier this year, NASA's Aeronautics Research Institute awarded an 18-month, $275,000 funding award to continue research and development of the alloy that can self-repair damaged parts using liquid-assistant shape memory metals. Clara Wright is a materials engineer in NASA's Engineering and Technology Directorate and the principal investigator for the SMASH project. She works in Kennedy's Failure Analysis Laboratory, where experts determine why structures break down and how to avoid future malfunctions.
As we move on, we can see a lot of application in the future. We've gotten results to show us that this is a very viable type of material that can be used to repair fatigue structures. We would use it in such areas as on an aircraft where you have wings, a lot of cyclic stresses, and fatigue is a big problem. It's very prevalent, especially in aerostructures.
For a spacecraft traveling far from Earth, a repair shop would not be an option. Being able to perform repairs on the spot could be the solution.
The SMASH technology is a metal-metal composite, and it has an aluminum matrix. We're trying to work with aluminum because that is a structural material. And you can use that in aeronautics applications, in aircraft. What we want to do is have it be designed thermodynamically so it has a low melting phase. Also within it, it has reinforcements made of shape memory alloys. Now, a shape memory alloy is an alloy that wants to retain its shape. In our case, we're using the wire form. And the wires, you can bend it any shape that you want. As soon as you bring it up to a particular temperature, it wants to go back to its original shape.
If a crack begins in the area where SMASH alloys have been used, the shape memory alloy's wire reinforcements will stretch across the crack. Heating in the wires will pull the metal crack surfaces back into the original shape, and the elevated temperatures also will cause low melting phase in the alloy to become liquefied to fill any gaps.
This technology could be used for any deep space type of exploration, human or non-human, where you could have something detect the crack and have a non-contact heating source come up to that area and repair the crack. We also are looking to see if we can have some of our material exposed in the International Space Station, outside of Space Station, to see if our material would be able to have the same repair capabilities in space that it does here on Earth.
Putting a technology to work in actual aircraft or spacecraft is still a few years away. Once put into use, safety margins would be improved, whether on an aircraft flying near the Earth or a spaceship traveling far from home.
Our team is so excited to be able to work on this. We can see a future that this could be something that could be applied, an application 10 years down the road. And our hopes is to use it not just for space, but also to be able to give it to commercial entities and be able to use it in other applications as well.